Hello, welcome. Let's try to solve another Leetcode problem, 2233, maximum product after k increments. So we are giving an array of non-negative integer nums and an integer k. So in one operation, we may choose any element from the nums and increment it by 1. So the return is going to be the maximum product of nums after at most k operations. Yeah. So this means we're gonna do each of the operation. So the operation gonna increase one of the number by 1. So for in this example, we're gonna increase the 0 5 times, so it's gonna be 5. So the final answer is gonna be 20 because 4 times 5 it's gonna be 20. And in the second example, we're gonna increase this 3 by 1, it's gonna be 4. And we're gonna increase this 2 by 1, it's gonna be 3. So the final answer is gonna be 216, and this is gonna be the maximum number. And let's just check the nums length, and k is going to be 10 to the power 5. Normally, if this is 10 to the power 5, it means we can solve the problem by using on or n log n time. Now let's just check what kind of method we're going to use to solve the problem. As the numbers can be really big, so we're going to need a mod, because the final answer is going to be modular on this mod. It's going to be 10 to the power 9 plus 7. Yeah. So let's just check if we can find some intuition from the examples. So in this example, it seems that we take a smaller number 0, increment 5 times, it's going to be 5. And for this example, it seems that we choose a smaller number, maybe 2, increase by 1, it becomes 3, and then the smaller number, maybe 3, increase by 1, it becomes 4. So the final answer is going to be the biggest number for all of the numbers product. But is this the right intuition or not? Let's just make a drawing. So normally for such kind of problem, if we are giving an array and if we are giving a value of k, yes, so for each of the time we can increase the numbers. We're gonna just check some intuition. Maybe we're gonna increase from the smallest number, or maybe we're gonna increase from the maximum number. We just need to decide which number we're gonna increase. So let's just make a drawing. Maybe it's gonna be helpful for us to understand the problem. So let's just make two drawings. So this is let me make a drawing. This is a country. It is a small country. It is a smaller one. And this one, it is the area of a big country. Now, our target is that we're gonna use the multiplication of the smaller one times the bigger one. What it's gonna become. So currently, it is fixed because this area is fixed and this area is also fixed. Now, we want to increment by 1, and we need to decide which part we need to increase. Maybe for the small country, we're going to increase by 1. It's going to become this one. We're going to increase by 1. So the final result is going to be this one times this one. Yeah. And another way is we're going to, instead of increase the smaller one by 1, we're going to increase the bigger one by 1. It's going to be here. And the final result is going to be this one times the bigger one. So which one is better? You know, this one times this one, maybe this is 1, and this is like 15. So 15 plus 1 is going to be 16. So the final answer is going to be 16. Yeah. So if we, instead of increase from here, so what about we increase from here? So before it is 1, and this one, it becomes 2. And here is still 15. So the final answer is going to be 2 times 15. It's going to be 30. Definitely 30 is more than 16. Yeah. So according to this type of intuition, we should know that if we increase from the smaller number, normally the final product is going to be bigger. Yeah, because this smaller area is going to times the whole area. The whole area is really big. So if we increase 1 from here, so the final answer is going to be really big. If we increase from here, we just increase a smaller one. So it didn't increase so much. Yeah, so this is just the greedy idea. Now let's just use this kind of method to solve the problem. So we're going to use heapify to heapify the nums. So the nums is going to become a min heap. So for each of the time, we're going to increase the smaller number by 1. So let's just use for anything in range k. We're going to pop out the number. It's going to be n. It's going to be heap pop. So we're going to pop it from the nums. Currently, this n is going to be our smallest number. And then we're going to put it inside with pq and n plus 1. Yeah, because for each of the operation, we're gonna increase the smallest number by 1, and then we're gonna check all the smallest numbers, and we're gonna increase the smallest number by 1, and then the final answer is gonna be the maximum. Now let's start to record the final result. So for any number inside the nums, so the final answer is gonna be result equal to result times, let me use the result times this number n, and as the final answer is going to be a modular. So if the number is too big, we're going to modular it from here. And let me put the mod here. And the final answer is going to be this result. So this is also important. So for the mod, we have to put it here. So before we are calculating the final result, we need to calculate for each of the medium step. So the step from here, that means that the number is going to become bigger and bigger, and we have to mod it from here. Otherwise, we're gonna have time limit exceeded, because if a big number times a big number, for example 10 to the power of 20 times 10 to the power of 40, it really takes a time, because this is a big number multiplication. It's not like small number. It is not a 1 anymore. That is why if we put it here, we're gonna have time limit exceeded. Now let me just run it to make sure it works. It is not PQ. Currently, the PQ is nums. As you can see, it works. Now let me just submit it to prove it works. As you can see, it works, and it's pretty fast. And the time complexity, it is just from here. So it is a k log n time. This is n is the length of the nums, k is what we are giving. And now, if we put the mod here, definitely we're gonna have time limit exceeded, because the number multiplication, if a big number times a big number, it is not 01 anymore. It really takes a time, so it should not work. Let's just prove that. So as we can see, it cannot pass. Let's just wait for the final result. Normally we're gonna have time limit exceeded. We passed the 72 testing cases, but we cannot pass the last testing case. That is because we didn't put the mod in the middle of the operation. If we put it in the middle of the operation, so for each of the times, the number times multiplication gonna be 01 time. So for here, it is still O(n), and for here, it is k log n time. So the final time complexity gonna be, it's gonna be the maximum. Let me make it. It's gonna be the maximum of O(n) and k log n time. So it depended on this n and k log n. So this is gonna be the final time complexity. Thank you for watching. See you next time.